off we go. So we're going to finish up these slides on functions and tables. So we learned how to make functions last time. It was very, very cool. You say def, you give the name of the function you'd like to make. You say what it's going to take. These are called the parameters. They're little variables that get set to whatever you pass along when you call your function. And it just starts running all that code with whatever you pass along. So if you pass along 42, x is going to get set to 42. If you pass along 5, x will get set to 5 as a little variable. These things up here, the things that your functions take, those are little variables that just get set for the life of that particular call to the function. It gets set to a different value for different calls. And so we did some very cool things with that. We learned about grouping. Finally, I taught you how to do it in the full explanation way. And yeah, we have a bunch of cool examples. And we did some predictions as well. We made a function like, hey, you give me a child I've never seen before. Let's see how tall they're going to be by looking at their parents' averages. Like we'll get using the data that we've got, let's go around. Like if a parent, or if we know that the parent's heights were 66 inches, we'll go like between 65.5 to 66.5 inches. Let's see all the data that we've got and take the average of all those parents and their child's heights and then predict that. Somewhere in the middle, and that's a good estimate for what that unknown child's height might be. And so that's really fun. And yeah, grouping was the idea of just like, I have some categorical thing that I would like to see what they're all about. I would like to double up on all the chocolates, for example. Group by the flavor. How many do I have? I have 3 chocolate ice cream cones, 2 strawberry ice cream cones. But you can also group and then aggregate is the fancy term by saying what you want done when you've brought all those things together on the flavor. Like you've brought all the chocolates together. What do you want to do? Give me the average of all the values that you've brought together. All of the chocolate price averages, all the strawberry price averages, etc., etc. So that was grouping. It was cool. We had some fun. We made some graphs with Pokemon. And now we're here. So I would like to continue and talk about kind of like a cousin of the group operation. It is called pivot. And it's like a 2-dimensional kind of grouping. And that's really cool. It's what we say that it cross-classifies ideas. So let's go there. Let's look at the documentation for the dot pivot operation on a table. It's very similar to group, but also a little bit different. So it makes what's called a pivot table, if you want to look into that, if you've heard that before. If you use like Excel or something, maybe you've seen it. But you say pivot, your table's name, dot pivot, and then you give 2 column names. One that you want on the x-axis and then one that you want on the y-axis, and it's going to bring them all together and cross-classify. It'll make the most sense with an example. So let's go to an example first. It's going to give you back like a little grid. It's going to give you a 2-dimensional grid of, by default, again, counts. So let me show that to you. It's going to take 2 things. Let me give you an example, and then we'll come back to this slide. I think that'll be easiest. So let's go back to the cones table. Let me read that in again. Where was the cell that we made the cones table? Definitely before that. There we go. Here's my cones table again. Copy and paste. Read it back in. So there's my cones table. I want to, instead of grouping this time, I'm going to say cones.pivot, and then I'd like the flavor on the x-axis and the color on the y-axis. Those are 2 categorical things, and sometimes there's duplicates, like a bunch of chocolates, a bunch of dark browns. This is what a pivot table looks like. It's a 2-dimensional idea. It's a grid of ideas where you've got flavors on the x now and colors on the y, and then you kind of go together. How many dark brown chocolates do I have? 2. How many light brown chocolates do I have? 1. So you read it on both axes at once. That's how a pivot table works. And so going back to the slide now, this will make more sense. So it takes 2 things, right? The first one is the variable that you want on the column labels of the resulting grid little table thing. And that is the x-axis in my mind. And the second thing is the variable that you want on the row labels, the y-axis. And then you could do the same thing that you did with group, where you could say, you know what, don't just bring together these values and count them. I'd like you to average the prices or something. Give me the average price for those 2 dark brown chocolate cones. Give me the average price for those 2 pink strawberry cones. Give me the minimum price of all the ones you've brought together. You can aggregate ideas again, all right? So you have 2 optional arguments, you need to include both or neither. You say values equals something, that's your column label, and then collect equals the function you want to apply to that column label. So again, an example is worth 1,000 words, but do you kind of see what pivot's doing? So I said pivot by flavor and color. So flavors on the X, colors on the Y. Here's a bunch of flavors, here's a bunch of colors, and by default, it's counted them again. How many are in common? There's one light brown chocolate because I read off of those both axes and I see the one there. There are 0 light brown strawberries, but there's 2 pink strawberries. Stuff like that. So yeah, you ready to see the extra arguments to pivot? It's just like group, but they take names this time. You say values and collect. Values equals something, collect equals something. So let's say I would like the average price for all these aggregated things. So all the dark brown chocolates, we brought them together. We've given them one slot in this grid. I don't want just the count. I want the average price of those 2 dark brown chocolate cones. That's what I'd like to do right now. So I can say, all right, the values that I want you to pick out after you've done this process pivot, I'd like you to pick out values equals. I'd like you to pick out the price column stuff. And then what do I want to do? Because you're going to try to put 2 prices right here, right? You're going to try to put 2 prices because there's 2 dark brown cones. What do I want you to do to combine those values? I would like you, please. How do I want you to collect them? I guess is how you think about it, because that's the name of it. I would like you to average. I'd like you to apply np.average because you're going to get like an array of all those 2 things. This is what I want you to do. So this is pivoting by flavor on the X and color on the Y, picking out the prices of all the things that have those 2 in common, like the dark brown chocolates. And then you can't just it's not printing 2 of those, it's not printing both of those prices to you. It's going to do something and give you one number back. How do you want to create that one number? Average together the things that share to sell. That's what you're saying. Call that function, please. So apparently the average of the dark brown chocolate cones is $5.25. The average of all the pink strawberry cones is $4.40. And then everything else there is just one of, so it's like that was their original price. So that is how you say that. And that's a little bit different than the way that you would do that with a group, right? You could do this kind of with a group and make it like more linear. It could be like cones.group. Because we're kind of grouping by 2 things at once, all those combinations of flavors and colors. That's what we did. That's what we did at the end last time. So group by flavor, both flavor and color, in a list with those square brackets. We can say, and then what do I want you to do with all the values that you've placed there? Do an np.average of all the columns. And so this is the grouping way of doing the same thing. You see the difference? It's just all a bunch of rows now. Here's every combination of flavor and color. I'm getting every row like that. Every dark brown chocolate is $5.25. Every light brown chocolate is $4.75. And so it's up to you to decide like which of these looks better to you, which of these works better for your purposes. Sometimes it's nice to just have every combination in a row, and then here's the value you want for all those things that have been brought together. Sometimes it's nice to see the grid because you can very easily tell the zeros, right? And the zeros are sometimes helpful. Like, okay, there are no, I don't know. There's no dark brown bubblegum version of an ice cream cone. And that might be some information that you need when it's kind of more implicit in this output. All right, you kind of see the difference between grouping by multiple things, which gives you every combination linearly, and then pivoting, which is like you get a grid and you have those axes at that point that are separate. 2 ways to get the same thing. Yeah. Let's see. Let me give you a bit of a larger example where pivoting might make more sense. If we're ready for that, yeah. Let me show that to you. So I have got a fun data set from the Berkeley people. When you read it, we've got, it's called Education and Income. So they took like a survey of a bunch of people. They wrote down, they asked them, hey, what was your highest level of education, like high school, college, 2-year, 4-year, stuff like that. And then, yeah, let's look at it. Education, income, here's the table. And so they've got a bunch of different years. There's like when they took this data. So like they're doing it over time. So like they took a bunch of surveys in 2008 apparently, and they also did some more later. There's 1,000-ish rows of this. And then they're asking people, what's your age right now? What's your gender? How much college or just any school have you done? Like some of them have no high school diploma. Some of them have done some college, but not a 4-year degree. Like there's a bunch of different categories. And then you say, what is your range of income? And then how many people in the population that we surveyed were in that category. All right, so they were doing some estimation, or they were just adding up the people that they ended up surveying, something like that. So let's deal with just 1 year because there's multiple years in this data set. There's 2008. Let's deal with their last year, I think is 2014. So let's pick that out. We'll be like, go where the year. And the way that they stored which year it was, they just like put the actual day. They put midnight on the January 1st of that year for some reason. So 1/1/14 at midnight. Let's do those. And then let's also not consider the children because I think most children have very little income. That's kind of useless to do analysis on. I know I didn't have very much money as a child. So let's do where the age values, let's do like are not equal to that 0, 0 to 17. Because that'll pick out the non-children at that point. So now it's everybody that's at least 18. So we get some more interesting information that way, I would say. And so let's call this Education 2014. So that's just how you just have to look at the data set and know what you want. So that's what we want in this case. And let's see how this plays out, right? You got a bunch of different age ranges, genders. These are all categorical variables right now, right? Ages, genders, how much education they've had, and then also what their income level was. This is kind of like a range, but I guess because they split it up, you can consider it also a categorical variable. This is kind of your one numerical variable, your population count. How many people in that category, how many people between 18 to 64 who were female and no high school diploma, how many of them made over $75,000 in 2014? That's like a decent amount of money, right, back then. Not a lot, right? Usually education and income they match, right, in a way. So let's just care about educational attainment and personal income, and then how many people had those combinations of that much education and that much income. Let's do those, all right? So let's say I want to select which columns. That's 0, 1, 2, it's 3, 4, and 5, the last three. Columns 3, 4, and 5. So that's kind of data that I'm getting. Let's shove that back into Educ 2014. I'll just call it that now. That's the table I want to work with. Those values, please. And let's see what we get now. So I would like to now do a pivot. I want to know, right? I have these two ideas, these two categorical variables. I've got some people with no high school diploma and a personal income level, and sometimes there's duplicates, right? I'd like to know how many people, right? How many people had no high school diploma and made over $75,000? How many people who had only high school diploma and also made over $75,000 and everything else in between? A pivot where you see those on two different axes is a good idea here, I think. So that you would say this, you'd say Education 2014, that's our table now. I want to pivot with, let's have educational attainment. You could also do the index, but it probably makes more sense to type it out so you see what's happening. So on the X, let's do educational attainment, and then on the Y, let's do personal income. And we could do a pivot this way. And it's not very useful to count things because there's like, it always is doubled up 4 times apparently. Because you've got like there's 4 different age ranges at this point, like 18 to whatever, where were we? 18 to 64, 65 to 80. And then you have male and female. So there's 4 things total. That's why you see all these doubled up 4 times. That's useless to us. So instead, let's look at these population count values. Like those are the values I care about. So bring together all the values that I care about, the population count label. If I can spell population count. And what do I want to do after you've brought together all of these 4 population counts? I'd like you to add them up. So there's a sum function that we could ask it to call. So how do I want you to collect these population count values? I'd like you to call the sum function, please, on all of them. So that's how you say it. And now we've got an interesting looking pivot table, and you've got different levels. So you see personal income is going to be on the y-axis, and then on the x-axis was educational attainment. It went in an interesting order, just like alphabetical order, so it doesn't really matter, but no high school diplomas over here, and then these levels of, these different levels of income are over here. And you can see that it would make sense if you have no high school diploma, it's more likely that you make less money. Yes? And this is saying that with the data. There's very few people who have no high school diploma who are making over $75,000. Some of them do. They got really lucky probably, but usually education is, I guess I'm biased in the sense, but usually education is matched to income, right? And so you see that there's the most amount of people who are making a lot of money, the most amount in the survey, were the people who had a bachelor's degree or higher. So that's us looking at this data and inferring things, right? And you see, like, it's kind of all over the place, things like this, but you can easily see, all right, how many people with a high school diploma are making in 2014 between $25,000 and $35,000. You just gotta do that, right? Almost a million. Who in their survey group, or in like the state or something that they were estimating things for. But that's kind of a good use of a pivot table, because if you did this with a group, it'd just be a really long answer. But you can easily see by bringing together those two axes, like you can look at which values you care about at a glance and infer things, right? Like, all right, it looks like education is giving people access to more money, maybe higher paying jobs or something. So yeah, are there any questions about that pivot table? How we made it, what it's saying, how to read it? It's a useful thing to want. Let's see, what can we do? Let's do some cool stuff. Let's use some of our functions now just to make it fun, because what you get back when you do pivot is another table. And so you can talk about it at that point if you save it somewhere. Let's call these totals. So this is the pivot table that we've just made. Let's try to get the distribution of these values. I think that will be fun. Let's do the following. Do you see how, gosh, how do I want to do this? If I ask for a column, first of all, of this totals table, I can get stuff, right? I can get the bachelor's degree or higher. I can type this out, or I can say column 1, 0, 1, right? So column 1 is all the bachelor's degree amounts of money that people made for all those different levels of income. That's kind of nice. I can call functions on this. I can do math with this. We made a function before that was in our, like, one of our questions. It was called percents. Remember that one? Let me rerun this cell so that we have it again. But this percents function converted a bunch of numbers into their relative percentages for that group. So like we did this percents on this array, right? It was like, all right, the number 30 was 40% of the amount here. It's 30 over the sum. It's like how much weight does this number have? And this is all going to add up to 100% at that point. So that was our percents function. We can apply it here. So we've got a column of a bunch of numbers for the bachelor's degree or higher people. We can say percents on that. And you can see that the people making over $75,000, that was about 35% of the bachelor's degree holders. They were making over $75,000. So you see what percents is doing to this column? It's taking this value and like dividing it by its sum. And then it was like there was 66.75% of the bachelor's degree holders were making below $5,000. We just took that number and divided it by the total, and we got that value there. That's what the percents function was doing. And so we can build another table based on this and then display it. So the pivoting kind of gets us to some further goal too. That would be worth it. So let's make a table out of this. Let's be like totals. Let's select out this personal income column. And I kind of want to attach this as bachelor's degree or higher now instead of the actual number. So let's attach this column as the new column. Okay, let's do that. So let's select out the column 0. I'll steal this, copy it out for a second. So let's just take that and then attach the percents versions of maybe this column, and then we'll do like no high school diploma to see the differences. And that'll be useful because percentages are better because maybe they surveyed more people with a certain thing. So it's better to use percentages usually. Let's add a new column to this, a couple new columns to this chopped off table. Let's take the thing that we just did for our percents. Oops, I typed it twice. Let's call that bachelor's degree or higher because that's the percents version of bachelor's degree or higher. And let's also do the percents version of no high school diploma. Which column of this table is that? That's column number 0, 1, 2, 3, 4. Column number 4. You could also have typed it out. But if I do that, oops, I didn't want the spaces. Yeah. What I've done is I've just, this code has picked out this original column, it kept it, and then it took this guy, turned it into percentages, and then it took this guy, this whole column, and turned it into percentages. Isn't that cool? And now we can display this. So we use the pivot to get somewhere further, which is nice. And let's call this the distribution. Dist for distribution. So this is the distribution of income for people with bachelor's degrees and people with no high school diploma for these different levels of income. And if this is these are just like different ranges, you can think of those as categorical things. And I've got two different numbers for a categorical variable. That means I can make a bar chart. So I can say dist dot give me a bar chart on personal income. If I was extra lazy, I could say on column 0. Does the same thing. And now from the pivot table, I've extracted this knowledge, and you can see in graph form that it's very compelling. You should get a bachelor's degree. In 2014, you can see that the relatively so many people with a bachelor's degree were making over $75,000, and so few people without a high school diploma were making over $75,000. It's kind of, this one's going up, right, for a bachelor's degree, and then it's kind of decreasing with no high school diploma. It's less likely that you make more money. And yeah, from that data, you can, we made first the pivot table to get that data in a place that we almost wanted it. And then we did some extra secret sauce on top of some of those columns from the pivot table to be able to make this final graph, which is really powerful and cool. Are there any questions about how we did that? You kind of see the usefulness of a pivot table and just all those different steps at once and applying functions that we've made to do useful things. It's a good example of a lot of different stuff. All right, if we're gonna have a question for you to try, let's see, you don't have to write this down anywhere, but I want you to try it. It'll be with the Titanic data set. Let me go back up to my example of pivot because I want you to do pivot stuff. And so here's my pivot example. Boop. So using this knowledge, I'll leave this up here so you can kind of see how pivot works. What I'd like you to do is try to do the following. Try to read in our Titanic data set of all the Titanic passengers. I'd like you to find the total amount of money spent by all the Titanic passengers on their tickets, but I want you to use a pivot. Cross-classify them by their ticket class and whether they survived. All right, so I want to see on one of the columns or one of the rows or one of the axes, I guess, the first class passengers, second class passengers, third class passengers, and then on the other axis, you should have 0 for didn't survive, 1 for did survive. So those are your 6 options total, right? And then I'd like you to add up all of the first class survivors' ticket costs, all of the second class non-survivors' ticket costs. So that's going to be the kind of grid that you make where you collect not with the average, but maybe with a different function that adds a bunch of stuff up. Do you remember it? So yeah, try that. Let me give you all the code I just wrote today. If you want to look at our new stuff. Let me add it real quick to the code from class page. There we go. If you refresh the page, you should have the chapter 8 file. It's up to date with all the things we've just done. So, all right. Try to read in our Titanic data set and pivot in that way And you can also try to get the average price that they paid for all the survivors of a certain class. But I'll do this last one together with us, just do everything above that last bowl. Questions about the question? I think it'll be a good practice. All right, so I'll give you a little head start. And then I'll do it too. Get that Titanic.csv. You don't already have it. Someone can read it in. And try to do a pivot. See which class the passengers are in on one of the axes, and then the survivor status of that particular class on the other axis. Like it should be 6 options total, right? Because you have survivors and non-survivors on one axis, and then it's like first, second, or third class tickets on the other axis. So give that a try and ask me questions if you have any as they come up. I'll give you another minute to try. But you're not going to want the average, right? You won't want that average. You'll want something else. And go from there. Release that. All right. Did any questions come up as we tried it? Did it make enough sense? Because you could have tried it on either axis. Well, let's try both. Maybe that'll be fun for us. But let me read it in. Titanic equals table, read table. So there's the Titanic data set, and then let's pivot, right? We want, on one of the axes, right, Titanic.pivot, I would like, it's going to be P class, passenger class of their ticket, and then survived, right? Those are the two things. So we can do survived and P class, or we could do P class and survived. So this one's going to put survived on the X and passenger and the class of their ticket on the Y. There are apparently 372 third class passengers that die. That's how you can read that. Or you could do it the other way. You can be like P class on the X. The default is just counting things. That's not yet what we want fully. This one is just the other way, right? Now you can see, like, all right, how many second class passengers survived? 87 of them. So that's how you can read that pivot table. But we don't just want the numbers. We would like their ticket prices, right? We want the money that they spent on their tickets. So when you bring all these second class passengers who survived together, I don't just want you to count them up. I want you to tell me about their fare. Their fare numbers. Those are the values I care about you aggregating, please. So you say values equals the fare column. That's what I want you to look at when you bring together all those people. Values equals fare, right? And then what do I want you to do to all those fare values, because you've got like 87 of them for the second class passengers who survived. What do I want you to do? What a function should you apply to that list of all of those 87 people's fares at this point? How do I want you to collect the data together? I'd like you to sum them up with the sum function, right? That is the function that takes an array and gives you back the sum of all the things. And so that gives us our final answer there. So how many second class people who survived, how much did they spend in total on their tickets? Almost 2,000 British pounds. Beautiful. So yeah, that's how you can read that. How many first class passengers who survived, how much did they spend on their tickets? Almost 13,000 pounds. That's a lot of money, right? And so you can kind of see the relative gaps in how much money was spent on each ticket for the survivors and the non-survivors. Interesting to think about, all right? You could also do the average. What was the average price of a ticket for the first class survivors and the first class non-survivors? So instead of collecting by sum, like take those fare values and then call np.average in all of them after you've placed them together. So it looks like the first class passengers who survived spent on average more money on their ticket. That's very interesting. That's interesting. That I don't know if that implies something, like they tried to save the rich people or something. That's very odd and interesting to me. It looks like that gap is not as significant for the second class passengers who both survived or didn't survive. It looks like the third class passengers who survived or didn't survive is about the same. They spent about the same on their tickets. So it was just kind of up to chance, more or less, which third-class passengers survived. Didn't have to do with money at that point, in theory. But maybe it did a little bit for the second and first-class passengers. I'm not sure. Maybe that just means like their cabins were closer to a place that was more easily like able to get on a life raft or something. But that's cool to think about, I think, and that's pretty fun. Are there any questions about how I got these values? How I got these cells to do what I want them to do? All right. Let's do a few things now. Let's do, here's my last goal that we can just do together for fun. Let's make a function that gives us back both the max and the min, because we can't really do that right now. You can say, like, give me what's the cheapest ticket for the first class survivors or something. You can collect by the min function. That would totally work. It looks like some of them spent no money and got a free ticket or something. You could also collect by the max, like how much money did they spend, like what's the maximum ticket price of a first class survivor? A little over 512 pounds or something. Interesting. So like that's a thing that you can do. You can't do them both at once unless you make your own function to go here. Collect by your function, not just anybody else's. So let's make a function that gives back both the max and the min together as an array of both of them, because then you get back two things at once. And let's aggregate with that function, because then it'll give me back both of those things. So let's do this. So let's first make a function. I'll say def, I'll call it max and min. And maybe I should call it min and max, I don't know. But that doesn't matter. So you give me some sequence of values s. What do I want to do to it? I want to make an array of both the minimum in that sequence and the maximum of that sequence. So use those other helper functions and give that back with return. Does that make sense how max and min works? It's just a function that takes, here, let me call it max and min on like an array of a few things. Like if I call it on 1, 2, 3, 4, 5, it would give me the min and the max at once. It would give me back the 1 and the 5 together. See how that function's working there? It's going to return back to me an array of these two things, the min of it and the max of that sequence that I gave. So now let's apply it. Let's be like, all right, let's apply that function to max and min, to our fair collection values, and now it's going to print them out. You can see what's happening here. So for the second class survivors, the minimum amount of their ticket was £10, 50 pence, and then the maximum amount that they spent was £65 even. Beautiful. So that goes to show that you can make your own function if you don't have one that exists in the libraries that just like does what you want yet. Combine them so you can have what you need. That's really cool and really powerful. That's the whole point of functions. Make your own, do what you want. Any questions about that? All right. Let us do one more thing before I have just a longer example of just all the things that we've been learning. So it's very fun. Let's do that together. All right. The next thing I want to talk about a join operation on tables. It lets you kind of like attach the columns together in a weird way, like you're sewing them together surgically or something. Let me show you the join operation on tables, and I don't even have a slide other than this for it because it's really just all about examples. There's no other way to get it across. Joining just lets you combine things where things are equal, in a sense, all right, where things are connected. So, oh, sorry, it's the wrong join. There's a string join, and then there's a table join, sorry. Where are you? There you go. Tables join. You can say these things. So join on column 1, so table 1, hey, join using column 1 values, and then join it with table 2 on column 2 values. So it's a little weird the way that you call it, and the result, though, is going to make a lot of sense when I show it to you. All right, so let me show you join just as an example. But what it does is it's going to attach columns where they match. That's kind of what I want you to think about. That's the intuition. That's what joining does. So to join two tables, two separate tables. Let's have our cones table, and then let's say that I've got like a ratings table, or like, oh, what are these different ice creams rated or something? So make it just a blank table here. What kind of thing? Make array. We've got strawberry. We've got chocolate. We've got vanilla. Let's say we did like a survey or something. Stars. Make array. Let's do strawberry wasn't very highly rated. Chocolate was a little bit more highly rated. And then vanilla was the highest rated or something. Like that's my ratings table. So I've got two different tables, and they're kind of talking about the same thing, right? Strawberry, chocolate, and vanilla match flavors in this table. So I've got this column, this kind column in the ratings table, that's matching flavor values and flavor column values in the cones table. You see that? When I have that kind of overlap, I can join the tables together to make a bigger table where those things match. And so that's what a join does for me. I can say you can do it in either order, but let's start with the cones table because that was the first table we ever had. Let's say, hey, cones, I'd like to join you using your flavor column. I'd like you to attach your rows, please, to the ratings table. You put that in here. And the ratings table has a kind column where you have values that match things in the flavor column of you. That's how you read that, all right? So that's how you say that. And then if I press enter, I hope that you see what happens. What's going to happen here is it's going to take the original cones table, and it's going to attach everything that it could attach where the kind matches the flavor. That kind of makes sense. So it's going to add the stars column, because that's the new thing for the ratings table. The kind matches the flavor. It doesn't need to add another column, because those are already there. But wherever the flavor was chocolate or something, flavor was chocolate, we know that there was 3.5 stars, so it attaches that. So every time you see chocolate flavor, it attaches the stars column, and there was 3.5 for all the chocolates. Does that make sense what it's doing there? It's attaching that new thing because you had overlap. So overlap, it was a flavor for that table, kind for this table. That's where you say it. So cones, join yourself to the ratings table using where your flavor column values match the kind column values in the other table. That's how you read it. It's a little bit jumbled, but it makes sense eventually. And so that's how you do it. And so it's like every time you see vanilla, it'll say 4 because that was its rating. Just adds that stars column. And every time you see strawberry, it's going to add 2.5. It was a bad batch of strawberry ice cream, apparently. That's all join is. All right. So the one thing you could do that's in this thing is you could omit that column 2 label if you had it where it was called flavor again. Like instead of kind here, if it was called flavor again, where it was just the same name of the column, like it already matches. You don't have to say flavor, oops. You don't have to say flavor twice. You could just omit that if it really said flavor again, because it's like just go find the label of the column with the same name where it matches. So you don't have to give it, don't have to give the third argument if it was the same column name. Okay, that's all. And so that's what joining does. It attaches another table surgically, it sews it in wherever it has things in common. So like I found chocolate for it. Kind of, I think what it did is it sorted them so that it could find things easier. It's like, all right, chocolate, light brown, 475. That was one of the rows. Attach that row to this table in the way that it matches where the kind matches the flavor. So chocolate was 3.5. So okay, chocolate. Let's add the stars, and it was 3.5. Cool. It does that for everybody. Any questions about what .join is doing? See it? All right. So yeah, that's join. You could omit that last thing if it was also called flavor in the ratings table. So that's join. Yeah, let me show you just a longer example now where we can make some fun maps and things. I have an example from a service that they have in San Francisco where you can like rent a bicycle. Have you guys used it before? I sure haven't. But it apparently exists. It's called Bay Wheels. There's probably like an app or something. But you can either rent a bike that you pedal that's like not powered, or you can rent like an electric bike just for your time to get yourself around the city more easily and not have to like rent an Uber or something. So yeah, it's called Bay Wheels, and what they've done is they've posted all of their data about all the rides people have taken within the city, of course, because it's San Francisco. They give you that data publicly, and so we can see every ride that was ever taken by people who were using this app and who were using this system. And let me show that to you. It's really cool. So we got some public data that I stole from their website from the summer. And let me show that to you. Let's work with it and do the kinds of things let's do some data exploration and data analysis. Let's do some data science. So extended example is called Bay Wheels. And it's bike share. Bike share data. So I stole this from their website. You can get more updated ones if you want, but here's the table that I've got. I went and I stole read table. I'll call this trips. Data, it's 2025. I stole all the June 2025 Bay Wheels data. All right. And I'm going to put that into a trips table. This is every single bike share ride by the Bay Wheels users in June of 2025. Here's all the data that we have. There are almost 350,000 different rows. This is the longest data set we've used in this class up until this point. It's very cool to think about. So that's what we've got. And this is every ride that took place in San Francisco using this Bay Wheels thing. I guess I think there's some of it in like across the bay in like Oakland, Berkeley, and I think there's also this exists in like San Jose. But usually I think it was mostly San Francisco data here. But you've got rideable type means classic bike, like a bike that you pedal and it's not powered at all, or electric bike. Those are the two values that you get. Then you have times. When did these rides take place? Because like you use the app and you're like, all right, I'm renting the bike, then it unlocks itself, right? So it started at here. This is when their ride took place, and then ended at how long? Like here's when their ride ended. And it also, just for fun, you could do the math yourself, but it also calculates a duration in seconds. This was a 534-second bike ride. Getting down to where they wanted to go, and you have to like place your bikes at certain stations, right? You have to put them back on their little holders at the place that you ride it to, and so there's start station name and end station name, and these are the places where the person rented their bike, and this is where they dropped it back off after they were done riding. And so then the last one is member casual That's just like, those are the two values. Either this person was like registered in the app, or they just like typed in their credit card really fast and they didn't make an account. So either they had an account, they were a member, or they were casual, they were like a tourist, they're just using it for today. There was no use to make an account. So you can do some really cool data analysis with this data. I hope you can see. Let's do a lot of stuff. All right. I think a great thing to want to do is to look at the distributions of the data in this data set. Like, all right, we've got some bike rides and we know how long they all took. Let's see, like, how often did people ride bikes for usually? What was the distribution of ride times? How about that? All right. So let's look at all the bike rides that were under 30 minutes, because usually that's going to be most of them. Trips.where the duration values are below, and this is in seconds, but you can do math. You can be like 30 times 60, because I don't want to do that. So like that's how you can say that, right? 30 minutes are below 30 minutes, and let's call that like below 30. Or let's just calculate it quickly. See how that's most of the rows, like 327,000 out of 350-ish thousand. So most of the rides were below 30 minutes. So let's do analysis on just those, because some of them that were longer were like people who forgot to put their bike back or something like that. So let's use those. And then, so with that, that's my below 30. Let's make a histogram, right? Because a histogram is going to show me a distribution of numerical data. Let's do it on the duration. Show me a histogram of the duration of all those bike rides that were below 30 minutes. Let's do duration, and then the unit it's in seconds, right? So you say second there if you want to attach that. And so here's the default 10 bins. You can see that a lot of the bike rides, not a lot of them were super short, below like 250-ish seconds, but a decent amount of them were under 500 seconds, which is 6, 12, 18, 24, 30, like under 10-ish minutes. Like the bulk of them were around this sweet spot of amounts of time. Isn't that cool? And so you can make your own bins. These are the default bins. You could also tell the histogram, hey, I don't want to make my own bins, but I want more than the default 10. You can also do that. So let me show that too, just in case I haven't shown to you. You say bins equals, and then you say, you can either give a number and it will make that many bins that are of equal length, or you can give your A-range stuff where you make your actual bins yourself. But let's do it more fine-grained. Be like, all right, give me a histogram of the duration, please, and make 60 bins for me. So that's more fine-grained. Isn't that cool? So some of them were like, a lot of these very small ones were probably accidental, like, oh, I just bought a bike, and like they put it right back because they're like, you know what, I'll just walk. Something like that. And then you see that the sweet spot is around 300 seconds, it seems. Like a lot of the rides were about 5 minutes long, getting people to where they needed to go to get to like their bus stop or whatever. I don't know. That's kind of interesting. And then it kind of very smoothly drops off. Most people were not riding over like 100 or 1,000 seconds, which is how many minutes? A little over 15 minutes. That's kind of cool, right? So that's some interesting data all by itself. Are we remembering what histograms are doing and how they work and how I made these? Does that make enough sense? So that's a cool thing that we can discover just by looking at a histogram. That's pretty nice. So let's see. We can also do like some groups and some pivots, right? We can say we've got this below 30 table. We can group it by, let's do like the start station name. Like where are these, how many people started at 62nd Street and Claremont Street corner? How many people started at MLK Junior Way corner and University Avenue, the corner of those two streets? Let's do that. All right, so start station name. That's what a grouping does, and by default it's going to count, right? By default it's going to count. It's going to take a while because there's 350,000 things, but it's going to aggregate them all together, and it's made this giant thing, right? There's a lot of them, and you could sort. You could sort this by like, all right, what's the most popular stations to start a ride from? You could sort by this resulting count column, right? Sort by count, descending true. This is going to take a second though when I run it, because it has to do a lot of work to count all those 350,000 rows. and bring them together. But it looks like the most popular station was the Caltrain station in San Francisco. Like people were getting off of the Caltrain right there. They're getting on a bike so they can go to their like the closest bus stop or whatever to get them where they needed to go to their jobs or something. The next most popular station was the corner of Market Street and Stewart Street, apparently. And this is how many rides out of the people in June were starting there. How many rides were starting there. So it's kind of cool to see that. And you can see, if you sort it the other way, what was the least popular station to start a bike at? That's kind of fun. So that's a grouping. Does that make enough sense? Us using that to notice things. Just shout if you have any questions about this, because this is just us exploring the data, right? We can also take these rides that were below 30 minutes and we can do a pivot, right? We can do, you better believe that if we could do start station, we can also do end station. So let's do the grid of like start station here and end station here. Like people go in different places. Let's do a pivot. Pivot on, it was start station name and then also end station name. And then I'll change that to end. So I guess start on the X, end on the Y. It's going to take a second again because there's 350,000 rows. But it's going to aggregate them all together, and by default, it's going to count how many rides were here. A decent number of these started here, started at 10th this street, and then it ended at the same place, like they were just doing a little loop. Like they went to the market or something, and they came back. That would make sense, coming back to the same spot. So a lot of them overlap, but and then some of them don't make sense. Like nobody started at 10th Street, University Avenue, and ended at 10th Avenue, 15th Street. Like nobody did that for some reason. Maybe they were just too close, or it was useless. But that's kind of fun to think about, right? And some of these are more popular than others. You have to show the table to see everything, but you can kind of see like some of them are popular. It's like 10 people or 26 people. That's the biggest number I've seen, I think. 26 people started their ride at this cross street and ended it at this these two cross streets. That's kind of fun. That's what a pivot does, and that's the difference. Are there any questions about that? See it? It's really cool, really powerful. And you don't just have to count, right? Pivoting, just like for grouping, you could do other things. Maybe we can get like, what was the shortest, like, what are the records for June? What's the shortest ride between like, of these 28, what was the shortest duration ride between here and here, right? Excuse me. So it's like the same spot. Maybe they went to the market. What was the shortest market trip or something? And so you can do that. Instead of pivoting just by default and like counting things, I would like you to use not just the counts, I'd like you to use as my values the duration. So aggregate them all by duration. And then what I want you to do to every duration is apply, how do I want you to collect the data as it comes together in those same locations. Call min, please. So that's kind of fun. So now it's going to find me the shortest ride between all those two station combinations, all those pairs of stations. Isn't this fun? And then it's zeros when sometimes it didn't actually, like when there was no ride there. So like it looks like the shortest ride that somebody did between the same station, 10th Avenue, East 15th Street, and coming back. The shortest market trip, or whatever they were trying to do, was a little over 3 minutes. That's so cool. This was definitely an accident, right? This was a 3-second ride. They're like, oh, I don't need this. Accidentally bought it. Let me put it right back. That's kind of funny. And then some of these, they're a little bit farther away from each other. Like these are not the same ones, right? 10th Avenue, Irving Street, all the way to 11th Street at Natoma Street. That was a long ride, but that was the record. That was the record for June. Maybe you can beat it next month. All right, but that's kind of a fun thing to notice. Like, give me the minimum duration for all these different pairs. That's how you can ask that question. Does that make sense to us? All right. The next thing I've done is I've made another data set that has these station names on them. So, and where they were. So I made a stations table. Stations.csv. So here's all the stations on the routes that people could go to. And so this is like here are all these station names, and then here's their latitude and longitude, like where they were on the map. So if we were to draw a map, and we're going to do that today, it's going to be fun. But you better believe I've got a column that matches other columns now. I could be joining stuff. That's another thing we could be doing, okay? So first of all, let's just take a look at all the stations. There is, it's a really cool feature of our data science library. Let's just make maps. It's kind of not easy to find the documentation for it. It's here somewhere though. Is that marker? Can I find it here? No, it's not even on here. I think it's on this table. It's on this page somewhere. It might have to like go out. Yeah, that's not exactly what I want, but maybe it's in the tutorial section. Yeah, there's like a drawing maps part of this, of here. Like this is how you do it. Got all these different ways to draw maps, and it's called markers and things. So let me show all that to you. And yeah, there's some documentation on it if you want to find it. It's on the first one. You have to like click the link, go back to the main page. There's like a making maps table, or making maps page. But yeah, let me just show you how it all works. I'm not gonna like really test you on this. It's just something that you could do. So there's a bunch of different kinds of maps that you can make. One is like based on markers. I guess I do kind of want to show this to you though. Drawing maps. Is there documentation on any of this? Not really. But this is kind of how you do it, at least. So let me show you that with that in mind. So you say marker, using the marker kind of mapping, please map my table. And the table is all of these stations, the stations table. But you have to rearrange the columns. The latitude and longitude have to be first. So I'm going to select every column of this table, but I'm going to reorder them so latitude and longitude are first. We'll do lat first. Then that's what it expects in order to make the maps properly. And then station name can be last. So all I'm doing when I'm selecting this table out, here, let me just show that to you. All I've done is just take the table and just rearrange the columns. Lat and long come first now. So that's the first thing you say. And then it also doesn't like station name. If you want to have labels in your map that you can click on and use, the thing that's not latitude and longitude needs to be called labels. It's really weird. So instead of calling it lat long station name, we're going to call it relabeled station name to labels. So now it's lat long and labels. That's what it expects. And then it's happy. And so if I run this, marker map this table, this particular kind of table with those orderings, I get a really cool thing. It makes a map for me that I can explore. So here are all the different spots that you could rent a bike from. A lot of them are in San Francisco, of course. And it makes little markers for each of them. And so this was apparently Golden Gate Avenue at Polk Street. Cool. Isn't that fun? So here's where all those stations were. San Francisco, across the bay, and then also down in San Jose. Just a few of them. But you can see exactly where they are. Isn't that fun? I like that. Nice. So that's how you make the map. Definitely go back to that and explore on your own time. It's really fun. But let's look at our table. We got all these different, right? We got all these different rides below 30 minutes. Let's put them on a map. Let's try that. All right. Let's figure out. Let's deal with start stations first. Let's find all of the like the rides that started at certain spots. All right. So let's take this table. Let's group by the start station. All right. Group by start station name. So if I do that, right, what it's going to do is give me all the start station names and how many rides started at those stations. Let's count. Let's sort by that count again. Descending equals true. And then I'll call this like starts. So now I'm going to find like the biggest ones first. That's more fun for me. So here's a table called starts now that has the start station name and then how many rides started at those stations. And also with all these names of stations, I have this stations table that tells me where they are. Do you see how the station name column, those values match with the start station name column values in this table? I could join on those values. All right, that's what I want to do. So I want to say starts.join, where you've got your start station name column. I'd like you to join this table, please, and all its rows with the stations table, and its station name is the name of its column that has the matching stuff for start station name. So join with the stations table, we say we join on this column. So that gives me this. For every name, for every station name, I've now attached the extra stuff that was in the other table, the latitude and longitude. So now I've got the counts, the latitude, and the longitude of all of these places. Does it make sense, the join that I just did? Attached all the stuff from the stations column, which was the latitude and the longitude where the station name matched. Let's call that starts. Starts equals that now. That's the starts table I want to map stuff with. And then if I want to make a table that I map stuff with, again, I have to have latitude and longitude first, and then I can do other things. All right, so let me show you something. I don't know if I want to type this out because it's not something I'm really going to test you on. It's just cool. So let me, for that reason, go here. I'll just copy it and it's faster. Well, I'll explain what I've done at least, but it's a little weird. I'm going to make one last table here called this. I'm going to say start map data. Oops. Sometimes it doesn't copy. There we go. So here's one last thing I'm going to do. I want to make this table because that thing, it expects the latitude and longitude first. I'm going to select that out. Latitude, longitude, start station name. And then I'm going to do some things, right? This count, what I like to do is make a map where there's like circles for every station, and the circles are bigger if people use that station more. That's what I'm trying to do right now. I want to make bigger circles for those stations. And so you make it's a column and you call it areas. That's the areas of the little markers that we're about to make. And you just give it some number. I found that if I multiply this count value by 0.75, it's a good size. And then you say colors. You can label these, you can put these labels in different colors. I'm just going to say blue for everybody. So that's what I've done. And start station name is now called labels. So the map software wants latitude, longitude first, then labels for when you click on your things, areas for how big you want your marker to look, and then colors can be whatever color you want the marker to be. We'll just make them all blue. All right, so it's a weird thing that I've just done here, but I've made a table called start map data in the order that it expects. And areas, the way I made areas was I took the count column. I took the count column and I multiplied it by 0.75 because that's going to give me the right kind of size in the final map. It looks better that way. But I'm just trying to make some number that is bigger when there's more people writing. It doesn't have to be the same number. It just kind of controls how big the marker is going to look on the final graph. It's like a heat map kind of thing, if you've seen that before. And so I want to make a map not of markers, but it's called just circles of certain sizes. Circle.map table with this table that I've just done, start map. And so those areas are going to look kind of fun. And here's how you see it. So I can zoom into San Francisco. See how it's making bigger circles for more popular stations, right? Let's try to find the biggest one. It looks like maybe right here's a big one. Market Street and 10th Street. It's a very popular station. And this one's also really big. Market Street at Stewart Street. Cool. Oh, that's a huge one. That's an even bigger one right there, huh? What's that one? That's the Caltrain station. That's where people are getting off the Caltrain trying to go into San Francisco. Or away from San Francisco. That makes sense why that one is so popular. So we made this areas column based on the number, this count column, the number of people who had a ride starting at that station. So that's how we did it. And so you can see some stations are not as popular as others, and you can get some interesting facts from this. Right? You can do the same for Oakland. You can do the same for San Jose. And it's fun. It's fun to think about. What's the most popular station? This one. That's some probably another Caltrain station. Yeah, it's a giant mesh of different train tracks. That makes sense. That one's going to be the most popular. Everybody's trying to get there or start there to go home. Right? You can do the same for the end stations, couldn't you? But yeah, that's just something that you can do. That's the a way to map things. It's really very powerful, right? Very, very cool. Any questions about that? Just a bit of an extended example using some stuff that we learned. Let's see. I think some of the last things I want to do are, let's explore one more data set maybe. Yeah, one more data set, and then that'll be it for the day, I think. Dun, dun, dun. So here, let's be done with this example. Let's go to just like, I'll just make like a little dividing line. We're doing other things now. There. Here's my next slide. So that was a fun example. Let's do some function stuff now, like making our own and using some ones that have already been made. Let's go back to our Fresno data set for the temperatures, like the record temperatures for Fresno for max and min. And then let's make a histogram. Let's make a histogram and do some cool stuff there. So let me read in that temperature data. Boop. Just like that. So there's all my temps stuff. And kind of what I want to do is, let's see. Let's do a few different things. I would like to really, now what's the first thing I want to do? Let's do this. So here's my goal, right? We've got a bunch of records. I'd like to make and figure out when were the most recent of the records. So you see how on January 1st, you got some records, like the high record was set in 1998 and the low record was set in 1976. Let's remember the more recent of the 2 years. So I'd like to do the maximum of these 2 years, right? So I'd like to be able to do this, like give me the maximum between like 1998 and 1976. Because it'll give me back 1998, right? Let's do that for every one of these dates and find the more recent record. Either it was the highest high or the lowest low. Give me, like for this one, 48 and 76, like give me 76 back. Because that was the more recent after 1948. So I want to do that for every single row in this table. That means I want to apply the maximum function to the highest high year column and the lowest low year column. If I were to do that, it would apply max for every row, right? It would use this value and this value and give it to max, and then it would result in whatever it gave back. So let me show you that. So that's this. This is saying temp, if we did this, temps.apply the max function, please, to, and you can give as many columns as you want to the max function, right? Whichever things you want to take the maximum of. I want to find the maximum of the highest high year for every row and the lowest low year for every row. What was the more recent year? That's the maximum year value. And this will give me back the maximum year that each of these dates was, each of these temperatures was set. So for the first one, it was 1998. That was the highest high year that had the record. Then for the next one, it's going to be 76, 76 again, right? All the way to like 2018 for this one, because that one wins over. So I found the most recent year that was a record, either for high or low. And let's make that table now. So using that as a column, let's say temps with a new column, like what was the most recent record year? Most recent record year is all that. We can do this on another line, maybe. There. And that's me making a new table. Maybe we can call it like recents. Yeah. There we go. So I've attached now most recent record year to all of these columns. So it's found the bigger of the two, lowest low and highest high. Does that make sense how I'm using apply there to get that and add that column? Because now we got one value now. We got a year value for every, that's useful for every date. And I would like to make a histogram now. Let's figure out how often different records were set. Is it more recent that we've been setting records? So that's kind of how I want to do that, all right? So let's see here. Dun, dun, dun. Yeah, we can try to figure out, because like there's a different range, right? There's a different range of all these values, isn't there? So Like for most recent record year, what's the range between them? Like recent dot column most recent record year. That's like the spread. So here's the entire column of the most recent record year. You can get like the max and the min. It was 1895 all the way to 2025 that we had records. I'm sure it's been updated so far since then. Who knows? But we can also get both of these at once, right? Because I made that function. It was called max and min, wasn't it? This one. I could apply max and min to that column, and it would give me both back at once. That's kind of cool. Use the things we've made. I can say max and min to that column. Like, okay, yeah, all the values are between 1895 and 2025, but that's not the full story, right? I would like a histogram to see, like, all right, is 2025, like the more recent years, are we usually setting records there? All right. So we can say recent.histogram on most recent record year, that column that I generated. And now you can kind of see that, yes, the more recent record year tends to be more recent, if that makes sense, right? We're setting records more often in this millennium for sure. See how it's getting higher as it's less likely that we had a record that was recent, like the most recent record for a day was like 100 years ago. That's crazy. But these bins are maybe not what you want. We know that the range is between 1895 and 2025. So like we can go by tens. Like bins equals np.e range 1895 to 2026, right? So we can go by tens and hit 2025. Let's use those bits. So like every 10 years. Now it's easier to think about. That's nice. So yeah, you can see that the more, like the records were being set more often in the past 100 years, for sure. It's very unlikely. It was a very, very extreme weather pattern to have it still be the record from back then. That's a cool thing to be looking at. Does that make enough sense? How we made that? Or you can interpret that? All right. Yeah, so max and min was a cool little function that we made. I kind of want you to try making a function now. Here's me making max and min, and we just used it in this way. I would like you to try with functions now. Yeah. So here's one last question for us for the day. With this in mind, there's that function that did max and min. I'd like you to read in that Fresno max and min temperatures data set that we had. And now I want to do something, all right? Let's say that I wanted to find like the differences between the highest high and the lowest low for every day. Like, for example, on January 1st, the record for the highest high was 69 degrees and the lowest low was 21 degrees. How far away are they from each other? That's 69 minus 21, right? And we can call that the spread of the temperatures, right? So their spread is whatever 69 minus 21 is, like 48. There are two ways to get those values, that spread for each day, right? Turn that one into that one. So these are like spreads for those days. Let me show that to you real quick. Temps. Like I want these values for every single day. So I want 69 minus 21. What was the spread of the January 1st records? And then I want the same for every other row too. Like, okay, the spread between 70 and 20, that's 70 minus 20. I want you to do that calculation for every row. Like it's going to go 48, then 50, and then keep going onwards. But I want you to do that for every row, please. There's a couple different ways to do it. The first way that you could make this happen is you can do math on individual columns, right? Get the whole column, do something with another column. You can do math, like subtract. That's the first way to do it. You could also make a function that you could apply to the table, make a function that subtracts two things and apply it to highest high and lowest low, which is weird to think about. Like you'd make a subtract function. Be like def. Oops. I don't know why that's unhappy. It'd be like def subtract x and y. And then you can make a function that like returns the result of subtracting two things, because then you could apply that function to every row of the table. So those are two different ways to do the same thing. You can do a column-based way of finding that spread of temperatures. You can do a row-based way of finding that spread of temperatures with the apply. I'd like you to try both. All right, so I'll give you a few minutes head start. Ask me questions, and let's see what happens. So let me give you all the code I've written up to date. There, so everything's up to date. Are there any questions about how you can maybe find these values? At least method 1. Try to get method 1 in there for the temperature stuff. Subtract those columns from each other. Try to find how far apart were those highest high and lowest low records for each day. Does that make sense? So yeah, give that a try. And yeah, that one was apparently 48. So you want to do that for every day. Method 1 is easy. Method 2 is a little bit harder. You can make a function, though, that you can apply to every row. See if you can do it. I'll give you a little bit of a head start. Interesting. All right, I think that was enough time. Are there any questions that came up as we tried that? Let me show you both ways. It's kind of fun. So I want like the spread of all this data so that maybe I could do a histogram, like see how it compares. there's a bunch of fun things that you can do to get that spread of all this data, like 69 minus 21, 70 minus 20. It's always highest high minus lowest low. Will always be at least a non-negative value. But the first way to do it, by just subtracting columns, maybe makes the most sense in your mind. Like you got temps, you can be like, give me the highest high year column, right? And that gives you every single value for highest high, right? That gives you all of them at once. You can do the same thing for lowest low year. And you can get the difference in dates. I'm sorry, I was supposed to be doing highest high. I can get the highest high column itself. And these are all the temperatures for those days, the highest highs for all those dates. And then I can subtract that with the lowest low. So take every highest high, subtract it with every lowest low. There's just as many as each other because there's one row, right? There's those two different data set, different pieces of data for every row. And yeah, you get the first one, the spread was 48, then it was 50, then it was 49. Interesting to see that. I like that. So that's one way to do it. Does that make sense? That's probably the easier way to get that differences of numbers. It'd be very fun to put this back in a table and do a histogram. Like see the spread, see the distribution. That would be great. Maybe we'll do that in a second. But the other way to do it would be to do it the row-based way. Apply a function to every row. There isn't really one yet. We could make our own one, though. Make like a subtract function that just subtracts values. That's all it does. Because we want to give it both of those columns, right? Subtract x on x and y. How do you subtract x from y? It's like subtract y from x. Just return x minus y. It's a very simple function. But we kind of want to run that in every day, right? We want to do the 69 and the 21. Have it get called to subtract with 69 and 21 and have it give you back that result. That would be, you say temps, there's our temps table, temps.apply, my subtract function that I just made. It takes two things, give it the two things we want to subtract. Do highest high first, and then do minus the lowest low values. Just give the names of those columns. It will apply that function to the value it sees in the highest high column and the lowest low column. Those will be the two inputs to the subtraction function, the two that it expects. And it will really do the same exact thing. This is just row-based versus column-based. Does that make enough sense? Are there questions about that? All right. If we're good with that, that's more or less what I wanted to say, at least in the slides. There's a few last things that I wanted to do for you. But here, for fun, let's make a table and do a histogram real quick. It'll be like table with a column, spread, I guess. Give it that. So there's my table, my spread table, and then we can do a histogram on spread. Cool. And so it looks like the most popular kind of spread is maybe in the summer where it's a little bit above 6 degrees difference between the highest high and lowest low records. It's kind of fun. Interesting to think about. Can make more bins, of course. But yeah. Before I release the last things and let you go off and work, there's a few last things I want to teach you that you'll need for an assignment. So it's time for my miscellaneous things section. Miscellaneous things I need to teach you. All right. The first one is the print function. I think I showed you this before, right? The print function just like lets you print stuff out. So you say print something and it prints that thing, but this lets you control what gets printed in the final output, because you can say print twice and it's going to run this and it's going to produce output twice now. Instead of the last thing is what you get, is when you say print, you will see that output. Whatever you put within print, you will see that output always. It kind of overrides just show me the last thing that Jupyter normally does. There's a big difference between when we made functions, right? We say return to give back a value. You may think, right, because you do 42 plus 28 or something, and you press Shift Enter, you give back a value. It's just printing it out. You may think right now that printing and returning inside of a function are kind of similar, right? Because that's kind of what's just happened, right? It just kind of prints out the answer. When you call a function, it returns back the answer. What's the difference? So I need to teach that difference to you. So let's make a function that called f. It's just simple. It takes nothing, and it prints 42. Then we'll make another function separate called g that also takes nothing, but it returns 42. There's going to be a huge difference, surprisingly, between f and g, but it's not apparent when you just call them by themselves. If you say f, you say g, running the code does the same thing as far as the output goes. Does that make sense? Like f, it runs all the lines, it gives nothing back, but it's going to print 42 because print makes sure something gets printed, right? So you will just see 42 printed out, but g returns 42, and you're seeing the result of g. And by default, Jupyter prints it out. So there is a very subtle difference here, but it becomes very powerful. Because normally, when you call functions, you want to use their results. F does not result in anything, so I can't be like f's result times 2. Does that kind of make sense? This will give me an error because f gives nothing back. It gives me back none. And it doesn't know how to multiply nothing by a number, by an int 2. F does not return, it does not give me back a value, and so I cannot use f's result because there is no result. Though it prints 42, you see that it prints 42 still, it's going to run the lines, prints 42, and then we're trying to multiply its result, though, after it's done all that by 2. There is no result. Does that make any sense at all? It's very weird, but that's kind of the moral of the story. Functions, if you don't say return, you're not getting back anything. You can't use its result because there is no result. Functions that don't return, including functions that just print things. Usually that's the kind of function you'll make if it doesn't return something, you're just printing something out. They give nothing back. The special type of nothing in Python is called none. It's fun to think about. But functions that do give something back, like g, it returns 42 back to who called it. I can totally do this. Because g results in 42. And then it's as if I multiplied 42 by 2. Do you see the difference there? It's very subtle. It's really, really subtle. Are there any questions about that? It's a really weird one. You'll run into this problem one day, but I just wanted to show it to you. All right? So usually we're going to want to make functions that return things in this class because I do want to use their results in some way most of the time. Put them in a table, something like that. So let's see. Let's make... So one last thing I wanted to show you, I think. Let's do... Yeah, there's 2 different ways to apply a function, weirdly enough. Let me show that to you. That is here. So there is a dot apply, right? We talked about it. There's 2 different ways to do it. Let's see here. I don't actually think it's showing that to you on this version of it. Function column. It doesn't have to take the column. It's very weird. Is it in this one? Aha, yeah, you could just say apply function. Here it is. Apply to the whole column or apply to some of the columns you care about. Apply to the whole row is what it's really trying to say. So here, let me, an example's worth a million words. So let me make just an example table. I'll call it T. With some columns, we'll do X is just 1, 2, 3. I'll just do this really quickly. We'll do Y is 4, 5, 6, and Z is something else. I'll make just a silly little table with 3 things in it. They're all numbers, though. So there's my table T, and here we can print it out too. It looks like that. It's silly. It's just got numbers. Let's say I'd really, really, really like to do the following operation on all the rows of the table. I'd like to multiply x's and y values together and then add the z. So like for the very first row, I want to calculate like 1 times 4 plus 7. Like I want to do that. That's something you might want to do one day. This example applies to it. So one way that you could do this is you make a function and you give it all 3 columns. It's going to expect all 3 columns. So def, I'll call it like multiply and add. It'll take 3 things. Let's call them A, B, and C so that we don't confuse X, Y, and Z, the labels. So, all right, you gave me 3 things. I want to multiply together the first 2 things, A times B. And I want to add in the third thing. Return that. Give that answer back, please. And then now this is a function I can apply to the table, right? I can say t.apply this multiply add function to all the columns in the order I want them. So like for the A's, give the X values. For the B's, give the Y values. For the C's, give the Z values. Then I'll get my 11, 18, 27. It will work. All right. So that's the way we know how to do right now. It's like have it take 3 things and give it all those columns. But if you have a function like this, or if you have an idea like this, where you just want to apply a function to everything, because it was every single column, right? Apply to all the columns at once. There's a way to make a function apply to every row, right? function, apply it to every row of the table, because this whole row, right, the 147 is the input kind of that we wanted, more or less. So there's a way to access individual rows of a table. So you say T, you get the whole table. You could say T dot, you know, like for item, you do like item 0 to get the first thing in an array. There's like a row thing, row 0 in the table. It gives you the whole row. It's kind of weird. So like that's row 0, here's row 1. Like you can get with indices. The first row is index 0, the second row is row 1. So back to row 0. You get the whole thing at once. You get the X, the Y, and the Z. You get it as it's called a row object. It's a little weird. But the second you have that, you can go into it and be like row 0 dot item, and it's called with its name, right? It's got the X part of it. Item X, that was the one. Item Y, item Z, out of that row 0. That's weird, a little weird, right? But the reason I'm telling this to you is there's another way to apply functions. You could say, you can make another function called multiply add that takes the whole row, and we'll do that. We'll pretend that in a second. And the way that you call it is you can say t.apply, the multiply add function, and then you say nothing else. Multiply add. I'm going to fill this in a second, but when you say t.apply without more things after it, after the function name, it will send the rows themselves to your function if you wanted the whole darn thing. Sometimes that's easier to type in. It does make the implementation of the function look a little weird though, because like, what do I want to do to this row that I've just been given? I want to take the X part and the Y part, add them together, and then multiply them together, and then add the Z part. It's a little weird, right? So it's like, all right, give me that row, give me the X item out of it, multiply that with the Y item out of it. It's a little more cumbersome, but that's okay. And then add in the item Z part of it. Return that. So if you forget or you don't say the labels that you want for columns to be passed to your function, it's just going to pass the whole darn row as this row thing, and to pick it apart you have to say dot item name of the column. So that's how that works. And so this will give you back the same thing, but it works differently. So if you don't add a column name after the function that you want to apply, it's going to apply that function. It's going to expect that your function took the whole row as one thing. Your function gets the whole thing passed to it. It's the whole row each time. It's the whole row passed to it. Okay, so that's the last weird thing I wanted to show you. You're going to need that for an assignment. That will come up. But now you've seen it at least. You can come back here and study. I think that's everything that I want to say. This is a very weird idea, but one day you'll want this, and you have to go with those dot item things. It's a little silly, but you'll need that when you do a function applying in that way. Okay, I think that's officially everything I wanted to say as far as lecture stuff. Are there any questions before I release your next assignments, or at least give you the due dates for them, because they're already released, more or less? Or technically there is one I still have to release. That'll be fun. All right. So we've got Lab 4, Homework 4, and a project. I want to talk about that one. So, okay, let's talk about due dates first, and then I'll introduce the project. So we've got, by the way, we had a due date for Friday, but I remember that Friday was a holiday, so I changed our due date that was supposed to be on Friday for Saturday. So you have one extra day if you want. So that was homework 3. Homework 3 is now due on Saturday, just like the check-in survey, because Friday's a holiday. You might as well have an extra day. Get it done if you need to. And yeah, so it looks like I can assign the next things due a week from today. Remember that there's also a holiday on Monday. Monday's also a holiday, so there's no class on Monday. But let's do the 18th for Lab 4. Then we can do the 20th for Homework 4. And then Project 1, I would like to give you a couple weeks for that one, because the project's meant to be a longer thing. All right, let me release it. But first we can talk about its due date. So let me write these down real quick so I don't forget them. So we've got we'll do Lab 4 due on the 18th. We'll do Homework 4 due on the 20th. And then let's do Project 1 due like a couple weeks from today. So like 1, 2, and then maybe the Friday of 2 weeks from now. So like 2 weeks and 2 days. That's plenty of time, I think. That should be a lot of time. That'll be the 27th. So like a couple weeks for that one, because that one's going to take some more time. You should start early, though. All right, so we'll do the 27th for Project 1. That's when it will be due, so like the end of this month. I think that's all that I wanted to say. So let's talk about that The lab and the homework are already out. I'll assign them due dates though, but the project has not been out. I need to release that. So here, we've got a new module and a page in it now. So if you go to our Canvas, you should see the project 1 file there for you. And here, let's open up project 1. It looks a little bit different. It's just a little bit longer, that's all. I'll show it to you really quick, but it's nothing that different. You always want to remember extract it. Extract everything. Sure, into that folder is fine. And then you can open up the notebook file. It's got a bunch of data sets because there's a theme to it. There's going to be a theme to every project in the class. There's 3 in the class. So this is like practicing things at like a more hardcore level, I would say. That's what a project is all about. Again, made by the nice Berkeley people. And it's trying real hard. But yeah, you can see you got a bunch of data sets that you'll be including, but this one is the theme is world progress. You have child mortality rates, you've got fertility rates, life expectancy rates of different countries. It's really interesting to see over time, like people are tending to live longer. That's a really cool thing. It's some good news, right? So that's what this project's going to be about. It's going to work in the same kind of way as a lab or homework, but there's just more to it. It'll take longer. That's all. So yeah, it looks the same. It's got a theme. It's really fun. And for projects, because they take longer and they're more work, I would like to allow you to work in pairs on your projects if you would like to. If you'd like to find a partner, you're welcome to. Just one partner, not a bunch, right? But if you'd like to find someone in the class, if you have someone in mind, go talk to them. You can post on the Discord if you want to. If you're looking for somebody and you haven't found somebody yet, maybe you guys can collaborate in that way, get together. But if you choose to work in a pair, which you are allowed to do for projects, I still want you to you'll get your files together. You'll some of you will do one part, one of you will do another part. Maybe you'll work together at the same time. I'd still like you to submit the final solution that you both made to the AutoGrader separately. And then also, please, if you could, put a comment at the top of your file saying who you worked with. So just at the top of your, remember that a comment is something with a number sign. So just at the top, where was that? You could say I worked with this person, and that would be easy for me to see and not get scared that you did. So put something right here, a little comment. Lawton Nichols worked with blank. There, now I know. So if you could do that, I'd appreciate it. But yeah, you're totally allowed to work with a partner for your projects because they take a little bit longer, and you'll be collaborating in real life too. So it's good to get some experience with that if you want it for maybe a future data science career. I think that's what I wanted to say. Yeah, any questions about the project or any of these assignments? All right, so I'll set those due dates on Canvas. I've written them down. And yeah, the rest of the time is all yours to work and to ask lots of questions. I'll be here. I'll get you all this stuff, and we'll go from there.